since CAD has turned in on itself, Niger is the only one doing that role. So now there are huge question marks.
Kabir, let's bring you back in here from Abuja. Let's talk about security and move the conversation on now. We've got a good sense of what's going on in Niger.
What is the difference between sound and noise? What is the difference between sound and noise?
So noise is like uncomfortable for the ears, and sound is like comfortable for the
Okay, you can say that if Arijit Singh sings a song, that is a sound, and if you sing a song, that is noise. Okay, chalo, sit down quick, come in quick. Okay, don't disturb this box in front of. Okay, सामने जो white box है ना, don't disturb that. Okay, so we have done a chapter called as pores, correct? Then we have also done a chapter called as friction, correct? What are the types of force we have? Contact and non-contact. What are the types of contact forces we have? Sit down there, go back. Muscular force and frictional force. Okay, and non-contact forces? Okay, gravitational, electrostatic, so many things are there, right? Okay, fine. So let us move on to another important and interesting chapter that is called as sound. And back benches, whenever you sit on a chair, be careful, it should not be a broken chair. Okay, be careful. Okay, look at this now. The chapter here, it is sound. No talking. Yeah. Yes, we'll discuss that. Okay. Sound is a form of energy which produces sensation of hearing in our ears. How is sound produced? That is the first point that we have to understand. Sound is produced by a vibrating source. Let us perform an activity to understand the sound. So let us do this activity. There is vibration which produces the sound. Imagine this is a metal pan and I am tying it to a rope and I take a stick and I hit it. What will happen? So when you strike the pan with this stick, okay, there will be sound. But how that sound is produced? Yes, because of the vibration. Okay, so the pan vibrates. So this is what is called as the production of the sound. Okay, so if you touch this pan, when you hit this stick on the pan, you can feel the vibration, and that is what is called as sound. Okay, so vibration is equal to the sound. Now for example, you have guitar here. So in guitar there are strings, correct? So the idea is you are going to vibrate the strings, okay, and then you produce a sound. When we pluck the strings of a guitar, so this is that guitar, strings vibrate and they produce the sound. When they stop vibrating, the sound also stops. Sound is produced as long as the object vibrates. Remember this. What is this? Drum. Now how the sounds in drums are produced? In a drum, it is a membrane that vibrates. That white color sheet which you can see, that is called as membrane. It can be made up of any material, cow's skin or plastic. When a person shouts, it is the vocal cords that make the air column vibrate. Okay. Now before going to this, tell me, if a man is shouting and a female is shouting, whose pitch will be higher? Whose pitch will be higher? Female. Okay, so remember this. Which kind of sound will be asked? Now here this is the sound box. Have you ever seen this kind of thing? In your home you may be having a home theater where this kind of vibration will be there. Okay. So in a speaker it is a diaphragm that vibrates. What do you mean by vibrations? Look at this. Consider this box to be a medium. The particles of the medium 1, 2, 3, 4. Imagine this is one particle. First particle, second particle, third particle and fourth particle. Okay. Now if someone disturbs the particle, okay, I am going to disturb the first particle. Okay, I hit this. What happens? The first particle moves and hits the second particle. Correct? Okay. Now the second hits the imagine the second hits the third, and the third hits the fourth. So this is how vibration takes place. Okay? The particle do not move from one place to other. They don't move from one place to other. They move to and fro about their same mean position. So this is called as vibration. So what is the definition of vibration? Read it out. The to and fro or back and forth motion of an object is termed as vibration. Okay. Now, if continuous disturbance is produced, the particles vibrate continuously. Okay, if continuously I am hitting it and there will be continuous vibration. Okay, like this. So this is called as continuous vibration and you can hear the sound continuously. Got it? So this continuous motion forms a wave. Got it? Sounds produced by humans. Now let us try to understand how the sounds are produced by humans. This is voice box. Okay, just see. Jagah hai kya? Is there any place? Come in quick. Come in quick. Settle down fast. Just be careful with the chairs on which you sit. Okay, just check it before you take that seat. Ready? And the wire में लो कर लिए Tanushree. Be careful. See, I think you are pulling it. Be careful with that. वो छोड़ दो उसको कुछ मत करो. Okay. Now look at this. How the sounds are produced by the humans, voice box or the larynx. Okay, look at this. This is your throat. Okay. The sound produced by humans. So this, can you see this pink color? Okay, that pink color which I am showing you now. So this is called as the vocal cords. Okay, there is a narrow gap and the lungs force air through the voice box. Okay, the air is coming out. Look at this now. Once again I am showing. Look at the lungs now. So from the lungs the air is coming inside the diaphragm. It is going inside the diaphragm and now it goes towards the vocal cords. Vocal cords vibrate and produce sound. You understand? So this is the vibration which makes the sound and we can speak. The muscle attached to the vocal cords can make the cords tight or loose. Okay, look at this. This is the muscle here, yellow color line, and that makes the diaphragm tight or loose. This changes the pitch of the sound. Okay, so that is called as pitch of the sound. Look at this now. Vocal cords. Vibration of vocal cords produces sound. Nose, lips, tongue. Vibrations are converted to speech. Okay, now it is advised that don't drink water immediately after you come from the ground activities, playing football or athletics or anything. Why?
Water will enter the lung.
Yes. One more question they can ask you like this only. Can you eat and breathe from the at the same time? Can you eat and breathe at the same time? No. You should never do that. That's why it is advised that when you eat, don't speak. Okay. Why you should not speak? Because when you are speaking from the lungs, the air is coming out and it is going in. And who is working here? The vocal cord is working. The body may get confused. Okay, the brain may get confused. So what happens? Sometimes the food, instead of going in stomach, the food may go here inside the lungs. Okay, and there may be choking up of the food. Do you understand? Take the chair from पीछे से ले लो दोनों, Ayush and Uttam. Do you understand? So this is one thing. Now in biology, we'll see there is one small part of the digestive system which will block the air and the food. Right now, you just see this sound. Speech is a production of sound that has a definite and clear meaning for us. Sounds produced by animals. I will show you some animals. You have to tell me what will be its sound. Arnav, look here, eyes on the screen now. Animals produce sound by means of the vocal cords. Dogs bark. Cat, horse, knees. Okay, next. Lion roars. Next. Cow moves. Okay, what about elephant? Map नहीं. I am not asking that. Tell me, elephant dash. What will be the sound of elephant? Yes? Yes, elephant trumpets. What is that? Elephant, trumpet. Sometimes they will ask you in reasoning. ठीक है, reasoning में पूछेंगे ये क्वेश्चन सब. Okay, next. Birds produce sound by the means of a syrinx. What is this? Syrinx. This can be your examination question. Syrinx. Syrinx. Okay. Animals they produce with the help of the vocal cords, and birds they will do with the help of the syrinx. Okay. Remember this. So ring of cartilage consisting of oval membranes. So look at this. Next you have myna, and you have parrots. Next, insects makes their characteristic sound by vibrating their wings rapidly. Can anyone tell me how mosquito sounds? हाँ, mosquito को vocal cords होता है क्या? नहीं होता है. Okay, look at this. Insects. Look here, everyone. Eyes on the screen. Insects will make the characteristic sound with the vibrating of their wings. So night time when you sleep, you can see, can hear the mosquito is coming towards you. Yes or no? Even in your sleep, you can see mosquito is coming towards. You can hear that. Why? Because the wings are vibrating. Do you understand? So look at this. Okay, mosquitoes. Then you have honeybees. Okay, so tell me what this guy is doing in his life. Collecting what? Collecting honey. Imagine if you see a honeybee, okay, which is flying in this classroom. Imagine in this classroom there is a honeybee which is flying. How will you identify that this bee is carrying honey or this bee is not carrying honey? But can you see large size? Okay, fine. Look at this. Look at this. Next is I'll explain you that. Imagine you have two honeybees here. How can we tell the difference between bees with and without honey? So what can you do? Bees with honey are heavier. Yes or no? The bees which will drink honey, it will be heavier than the normal weight. So can it fly easily? So it will fly fast or it will fly slow? Slow. That's it. Okay. So bees with honey are heavier and vibrate their wings less rapidly. Bees without honey are lighter. Okay, and vibrate their wings more rapidly. Now this I gave you an example of honeybee. In exam, if they ask you a question on butterfly, what will be the answer? How will you identify a butterfly is having honey? Yeah, how will you identify? Nectar. Ah, that's what nectar. How will you identify the butterfly is having nectar or not having nectar? Yes, it flies slow, and if it is lighter, it will fly fast. Okay, and don't tell me that, sir, you have taught honeybee in your class, not butterfly. And if that question comes, you're going to drop it. So there is difference in the buzzing sound. Okay, next, let us do a small activity. Sound travels through solid. Okay, let me take a. Okay, now these two candidates are here, are going to do an experiment. Imagine you have a steel scale. You hit this steel scale in one end, and you can hear the sound in the other end. Correct? Next, sound travels through solid. Next activity, sound. Let us do this exercise. You might have taken two paper cups, and on both the end I have tied a rope. Okay, and I have these two candidates. Okay, one candidate speaks from one end, and the sound travels in the other end. Correct? We have tried this kind of experiments. The sound of your voice vibrates, and that can be heard due to the vibration of the string. Got it? So this is the example of sound traveling through solid. Next activity, sound traveling through liquids. Imagine this is a beaker, and inside the beaker I have a bell. Okay, and I am vibrating this bell. What will happen? Will you be able to hear the sound or no? Yes or no? You can. You can hear. Okay. So look at this. Sound travels through water. So what is this? Dolphin. So how do they communicate? How do they communicate? Look at this. They communicate with the help of the sound. Okay. They communicate with the help of the sound like this. Do you understand? So dolphins communicate with each other using sound. What is? Yes, all the fish. Okay, almost all the fish. Actually, why I am giving you example of dolphin? Because dolphins are blind. Okay, they cannot see, so they communicate with the help of the sound waves. Okay, tell me which animal is the national aquatic animal of India? Yeah. Which which animal is the national aquatic animal of India? Yes, Gangetic dolphin. What is the answer? Gangetic dolphin. Okay, Alan, look here. Next, I'm going to show you something. You have to tell me what is that. Is it submarine or blue whale? Yeah, this is a submarine. Okay, and what is this? Okay, now if the submarine want to send a message to this ship, how can they do it? Yes, there will be sound waves. Okay, there will be sound waves. The sound waves will hit the. Look at this. There is a submarine down. I want to check whether the enemy submarine is down, and this is my ship which is floating on the surface of the ocean or sea. Now I send a sound wave down. It will hit back and come back to me. So this is how I will detect the like a submarine or something which is flowing under the water. So this is the logic behind sonar. Okay. Look at this. Ships and submarines communicate with each other using sonar. Okay. To show that the sound cannot travel through vacuum, let us do a small experiment. I take a jar. This is an electronic bell. Imagine. Okay, this is an electronic bell. I take a jar here, keep it in a jar, and place a cork on an airtight bottle. Connect the bell to the battery and the key, and now take take this thing now into a vacuum pump and switch on the plug key. So what happens? The current flows and the bell starts ringing. Okay, and now the bell starts ringing. You can hear or you can imagine that the molecules of the air, it starts vibrating. Okay, so due to this vibration, you can hear the sound of the bell ringing. Now next what I am going to do, I am going to start the vacuum pump. Okay, on the right side you can see I am going to start the vacuum pump. So when I start the vacuum pump, the air molecules which are there in this jar is going to come out. I am going to take all the air. I am going to take it out. Now there is no air inside it. There is no air inside this jar. Okay, so now what happens? Look at this. When I start, okay, when I start the switch again, the sound of the bell becomes fainter and fainter, and you cannot hear the sound. Okay, so this is what happens. So can you what is this experiment? I want to prove that sound does not travel in vacuum. Do you all understand? Okay, so tell me, sound travels in solid, true or false? Sound travels in liquid, true or false? Okay, what about vacuum? Yes. Yes, tell me what doubt. Yes, we cannot hear the explosions happening in the space because there is vacuum in space. Okay. So this is what the experiment is all about. Finally, conclusion. We can conclude that for the sound to be produced, we require a material medium like air, water, etc. Okay. Suppose you and your friend are on the moon. Look at this. Suppose you and your friend are on the moon. Will you able to hear any sound produced by your friend? Okay, so how did Neil Armstrong and Buzz Aldrin interacted with each other in moon? Yeah, radio. Why they require radio? Though they are just near, they can say like this, come. Yeah. Okay, look at this. This is moon. Okay, and these are the two astronauts on moon. There is no atmosphere. There is no medium, so sound cannot travel. Correct? So, but they can talk in terms of the sign language. Okay? But from the earth, the message was sent via the radio waves. Do you all understand? So, this is the first part. Next. Okay. Light propagates faster than sound, correct? So you here on the screen you can see two things, that is thunder and lightning. Yes or no? Thunder and lightning. Which will travel faster? Lightning or thunder? Light. Speed of light. Okay, let us try to understand why it happens like that. Have you heard a loud sound after lightning? Yes. It's a thunder. Okay. Now look at this. Why do we hear thunder after seeing lightning? Lightning strikes at a distance. thunder and lightning occur together. Always remember, both thunder and lightning occur together. Look at this. Speed of the light is 3 into 10 to the power of 8 meter per second. What is the speed of the light? Tell loudly. Meter per second. Okay, meter. This is the speed of the light. Okay, so the light is traveling at a very fast rate. Speed of the sound is 330 meter per second. What is the speed of the sound? Everyone tell loudly. खाली इनके लिए सबके लिए. Okay, 330 meter per second. Now in higher classes we'll try to understand what is called as Mach number. Okay, what is the speed of a Sukhoi aircraft or what is the speed of a MiG-21 aircraft? You have a topic called as Mach number. Okay, look at this now. Light propagates 1,000,000 times faster than sound. So as speed of the sound is less, then the speed of the light thunder is heard few seconds after lightning. Now we'll do some experiment. Look at this. Characteristics of vibration. So this is how one wave looks like. So one wave is equal to one oscillation. Do you all understand? So this is called as crest. Okay, the upper part of the wave. See, from here, if I draw like this S, can you see the S is sleeping here? Okay, this top part is called as crest, C-R-E-S-T, and the bottom part is called as trough, T-R-O-U-G-H. Do you understand? So one crest, one trough is equal to one wave, and that is equal to one oscillation. Okay, look at this. What is amplitude? The maximum displacement of a body on either side of its mean position is called as the amplitude. Suppose if you want to increase the sound when you listen your favorite song, what will you do? You'll try to use amplifier. Have you heard? Amplifier to increase the sound. Look at this. This is crest and trough. Second point, time period. The time taken for one complete oscillation is called as the time period. It is noted as second. Next you have frequency. The number of oscillations per second is called as frequency or vibrations, and it is measured in hertz. In the first chapter of units and dimension, I have told you what is the unit of force. What is the unit of force? Only Newton. Newton, dyne. Next. Yes. What is the unit of pressure? Pascal. Next. Bar. Okay. What is the unit of energy? Joule. What is the unit of electric current? Electric current. Ampere. Electric charge. Potential difference. Volt. Okay. Magnetic field. Weber. What is that? Weber. Very bad. Okay, look at this now. In 1 second, what is the wave? That is depends on the frequency. So look at this. This is one wave, and the second wave, if I show you, this is the second wave. Okay, so here I can say this is high frequency waves. Do you understand? So if you understand the topic of frequency, wavelength, etc., then in chapter light, we'll try to understand red light, why it is used in signals. Okay, look at this. This is the formula. So what is the formula for frequency? 1 by time. Okay, 1 by t. Okay, so this is one thing. Next, loudness. Loudness of a sound depends on its amplitude, and amplitude is less, sound is soft. Amplitude is more, sound is loud. Okay, and this is the equation. Loudness is directly proportional to the square of the amplitude. Loudness is directly proportional to the square of the amplitude. And what is the unit here? Decibel. So now in exam they will ask you, what is the unit of loudness of the sound? Answer is decibel. Loudness of the sound is decibel. So normal breathing you have 10 decibel. Average factory you have 80 decibel sound. Aeroplane will create 150 decibel sounds. Okay. So above 80 decibel, sound becomes physically painful. You cannot tolerate it. Okay, and you have another thing called as pitch. Pitch explains the shrillness in the sound. Okay, so frequency is high, the pitch is high. Generally, girls' sound is high pitch. Do you understand? Next, frequency is low, pitch is also low. Generally, boys' sound is low pitch. Okay, now here. Sound, you have loud or soft and high pitch or low pitch. Ready? So now you are going to tell me, you are going to fill it. What is this? Lion. So for lion, it will be loud or soft? Okay, if it is loud, what will be the pitch? High pitch or low pitch? High pitch or low pitch? Wait, from back I want the answers. Yes? Yes, answer is correct. It is low pitch. Do you understand? Next, what is this? Bird. Okay, for bird, the sound will be soft. Now tell me, high pitch or low pitch? High pitch. Okay. Now look at this. Can we hear all types of sounds? That is the question here. Can we hear the sound of drums being played? Yes. Can we hear the sound of pendulum oscillating? Yeah. Okay. Frequency of sound. Look at this. Type of sound. Okay. Look at this now. Very, very important examination question. Till now it was just a story, but now this slide is very important for your exam point of view. Okay. You don't have chair there? Try to come earlier. Class gets disturbed, no? Okay, just 5 minutes stand and watch. Idhar dekho. Less than 20 hertz. If the frequency of the sound is less than 20 hertz, what happens? This is called as infrasonic sound. What is this here? Infrasonic sound. Next, if the sound frequency is between 20 hertz and 20,000 hertz, 20 hertz and 20,000 hertz, okay, this is called as sonic. Okay, this is called as sonic. The range of frequency which humans can hear. So remember, above 20 hertz we can hear the sound, and less than 20 hertz we can hear the sound. If the frequency is less than 20, I cannot hear it. And if the frequency is more than 20,000 hertz, humans cannot hear it. Okay, next, look at this. More than 20,000 hertz, this is called as ultrasonic sound. What is this sound here? Ultrasonic. Now I give you an example. Can this sound travel in water? Yes. What about dolphin? How do they communicate with each other? So which sound? Infrasonic, sonic or ultrasonic? Ultrasonic. Okay, look at this now. Who is this? So where do we have Kaziranga National Park in India? Yes, correct. Where it is? Assam. Very good. Kaziranga National Park is in Assam. So rhinos, they can hear sound which is no till 3 hertz. Look at the sharpness of that ears. Infrasonic. Okay. Who is this? Okay, tell me. Elephant is a symbol of which political party? Elephant is a symbol of which political party? Bahujan Samaj Party, BSP. Who is that? BSP. And who is the leader of BSP? Mayawati. Who is that? Mayawati. Okay, look at this. So elephants can hear sound which is from 16 hertz to 12,000 hertz. Do you understand? Okay, now dog. Dog can hear the sound which is between 23 hertz and 54,000 hertz. Okay, sonic and ultrasonic. Dolphin 20,000 hertz and greater, ultrasonic. Okay, now pests 20,000 hertz to 40,000 hertz. So they are all ultrasonic. You understand? We are able to hear with the help of extremely sensitive device called ear. How does the human ear work? Now let us try to understand human ear, how it looks and how it functions. It allows to convert the pressure variations in air with audible frequencies into electric signals that travels through the brain via auditory nerve. Look at this, pressure variation. Okay, an audible frequency is, what is the frequency for the human ear? 20 hertz to 20,000 hertz. Okay, this is your ear. Now look at this, outer ear, middle ear, inner ear. This is called as pinna. The outer ear is called as pinna. This is auditory canal. Okay, so canal means, this is the canal from where the sound, the vibration is going to go inside it. Okay, the collected sound passes through the auditory canal. Here there is an eardrum. Okay, here there is a very soft eardrum. Okay, very, speaker mein aisa sheet hota hai na? Have you seen this kind of things in your speaker? Like that, there will be an instrument here. So at the end of the auditory canal, there is a thin membrane called as eardrum. Okay, now look at this. Next, what happens? It converts the pressure variation into electrical signal called as cholia. Okay, so from here, this electrical signals will be going here. Okay, and from here, now the signals will be going to the auditory nerve and it goes to the brain. Do you understand? It interprets as the sound. Okay, so this is what happens in your eardrums. Okay. Now look at this. Match the column. Okay, what happens? You have on the column 1 pinna, eardrum, auditory nerve, auditory canal and cornea. Okay, now batao. Pinna में क्या होता है? At the end of the auditory canal there is a thin membrane. Eardrum, what happens? The outer ear is called as pinna. Okay, now match the following. इसको करो. Pinna. The outer ear is called as pinna. Eardrum. Yes. Eardrum, you are telling at the end of the auditory canal there is a thin membrane. Auditory nerve. It sends what? Electrical signals to the brain. Auditory canal. And what about the last one? Okay, shall we check it? Correct. First one is right. Second one is also right. Third one is correct. Fourth one is correct, and automatically fifth one will also will be right. Okay. Now, persistence of hearing. Look at this. Persistence, continuous hearing. Imagine you are exposed to the sound for a long duration. This is the eardrum. When a given sound reaches the human ear, it affects the eardrum. Okay, and now the signal goes, electrical signal goes to the brain from the auditory nerve. It affects, the effect remains in the ear for nearly 1/10 of a second. How many second? 1/10. Okay, remember when you speak, every word should come at least 1/10 later, 1/10 second later. Imagine if I ask you one question and everyone is starting answering at one go. Can I hear it? No. Why I cannot hear it? Because all the sound in my ear, it is coming in, there is less than the gap of 1/10 of a second. Okay, so look at this. Here you have, this feeling of continuity is called as persistence of hearing. Okay, now let us do the last part here. Okay, so now this man is trying to speak in different direction. So what happens if you speak in this direction like this? Have you ever tried it? Okay, have you ever tried speaking in empty hall? In auditorium, what happens? Echo. What is meant by echo? Okay, tell me, world's largest dome is present in which country? Largest dome. World's largest dome is in which country? Okay, I'll give you a clue. It is in India. Yeah, where is that? Gol Gumbaz. Gol Gumbaz is the world's largest dome. What is special there? Yeah, eco. What is special there? Yeah, eco. Remember one thing, all the buildings built by the Islam rulers, okay, Muslim rulers, they have this characteristics of ecosystem. Okay, why they have this ecosystem? Because if the enemy is coming from one end, they can kill him from the other end. Or sometimes the enemy is going to get confused. Look at this now. He's going to speak, the sound goes and it comes back to him once again. So he can feel that someone is there on the other side of that mountain and he is also trying to communicate. So there is a, when science was not developed, there was a confusion. Okay, people were afraid to cross this mountain because if one person is shouting, there is the same sound coming from the other end. So people were afraid. Shaman, come forward. Okay, so this is what it is. Got it? But now the science is developed and now we have something called as echo. The repetition of sound due to reflection from a distant surface is called as echo. But what should be the distance, minimum distance? That is important. Look at this. Conditions required to hear reflected sound clearly. The human ear can distinguish between two sounds only if there is a gap of, tell me, between two words, what should be the gap between two words? 1/10 of a second. Okay, 1/10 of a second. So look at this. Human ear, and I'm trying to speak. I'm trying to say hello. The hello goes to your brain. Okay. Now imagine the brain processes the sound and we are able to understand it. Now imagine if someone is speaking hello. Okay, like this. And once again there is hello. I can hear it because the two hello came after the gap of how many second? 1/10 of a second. Okay. So when the two sounds enter the ear more than 1/10 of a second, both these sounds can be understood. Now look at this. Now here, can I understand what the person is trying to speak? No. Why? Because there is no gap between the two words. Okay, so the idea is, okay, what should be the gap here? 1/10. Okay, now echo can be heard only if the distance between the observer and the reflecting surface is how much? 17 meters. How many meters? 17 meters. Look at this now. Velocity is equal to distance by time taken. How did we understand that the 17 meter is the distance? How did we come to conclusion? Look at this. Distance is equal to velocity into time. Okay. So now velocity of the sound in air is how much? Yeah. Shreya, don't play with ball. Yeah. 330 meter per second. What is the velocity of sound? What is the velocity of light? Tell loudly. 3 into 10 to the power of 8 meter per second. What is the velocity of sound? 330 meter per second. Okay, so now what I do, distance 330 into time. What is the time I have found out? 110. So can I cancel this 0 and this 0? What is the distance now? 33 meter. What is the distance here now? 33 meter. What is half of 33? Look at this now. Okay, here there is a boy. Okay, look at this. Here there is a boy. He tries to speak. The sound travels. Okay, the sound should travel the distance of 33 meter. Totally the sound should travel how much meter? 33. So if he stands here and now look at this, only when the distance is 17 meter. So this is 17. The sound will travel from the boy to the mountain 17 meter. Again it will go back to the boy to 17 meters. So 17 plus 17 gives you 34. So at this optimum range, you can hear your sound once again. So that is called as echo. Do you all understand? Okay, now the question is like this. Imagine this is the classroom. Okay, and you go to theater. How many of you seen like theater, the corner walls? How many of you seen carefully? Okay, how it is? It is curved or it is huh? It is curved or it is 90-degree perpendicular? Why? Why is the question? Because there should not be any echo. Do you all understand? Okay, so look at this. So are these sounds coming from a construction site pleasing? Do you like this kind of sound? No. What about this guy? Workers at the construction sites wear ear muffs. Why do they do that? Because they cannot tolerate. Okay, otherwise it is not pleasing. Okay. Next, what about this? Do you enjoy the sound of a vehicle's horn? Yes or no? What happened? You don't have car. Then what's the problem? Or you enjoy it? Tell something, participate. You don't like. Unless and until you are outside the car. If you are in the car, you will like honking. Okay, in traffic. Look at this. You don't like it usually? Okay, what about this? Would the sound be pleasing if everyone shouted together in the stadium? Yeah? Yes, if it is our team. Okay, yeah, fine. Look at this. We did it. Maybe we have to change this word. Okay, look at this. So these are the examples. Sounds which are unpleasant to the ear. Okay, to hear, that is called as noise. So noise are nothing but irregular or non-periodic vibrations. What about this? When someone plays piano, do you like to do you enjoy that? Yes, definitely. Okay, next. What about guitar? Yes, it's pleasing to your ears. Tabla? Yes. Okay, so what happens? Sounds which are pleasant to hear are called musical sounds. Musical sounds are produced by regular and periodic vibrations. So noise pollution, you already know this. Presence of excessive or unwanted sounds in the environment is called as noise pollution. Vehicle noise, for example, silencer, some, yes, explosions. Okay, then you have speakers, correct? Then you have high volume in the television, correct? So look at this. Harmful effects of the noise pollution. Hypertension. Those who listen to high noise or those who always travel in traffic, they have hypertension. Okay, high blood pressure. Lack of sleep. You cannot sleep properly. Hearing impairment. Sometimes you cannot hear properly. Okay, yes, you have a loss Then you have measures to limit noise pollution. How to stop this noise pollution? You can fit silencer to your vehicles, conduct noisy operations away from the residential areas, minimize the use of vehicle horns, and play TV and music systems in a low volume. Okay, and plant trees in the residential building. It acts as a barrier. So vibrations will be stopped by these trees. Okay. So did you all understand this? Okay, so we have completed a small topic that is called as sound. Okay. And now we have an interesting topic here that is called as natural disasters. Okay, or you can say natural phenomenon. So let us try to understand that. Okay, have you heard earthquake? Okay, lightning, thunder, etc. Okay, now let us try to understand this. Some natural phenomenon. Okay, look at this. Studying after sunset was difficult once upon a time, correct? But illuminating around us is now in our control. We have, intensity of lights with LED and all these things. Electric bulb was invented by whom? Thomas Thomas Alva Edison. Traveling small distance would take hours together, but now what has happened? Long distance can be traveled in a short span of time. Got it? So electric train started. Next, washing clothes would take several hours. Okay, but now what has happened? Yes, cleaning clothes is just in a minute. Washing machine. So what happens? This is nothing but electric washer. Now, heating water would not be possible without fire. But now what has happened? Yes, boiling water is just at the push of a button. This is called as electric kettle. Correct? So what is common in all this thing? Yes, you have a word common, that is electric. Okay, look at this now. So they all run on electricity. So these are examples of current electricity. Charges in motion. In this chapter, we will talk about charges at rest. Okay, and then static electricity. Look at this. The lightning is striked on a tree. That's why people say don't stand under the tree, because the canopy is a very large area. It becomes a very easy target for the lightning to attack this kind of trees. So don't stand under the tree. So we have lightning. Okay, look at this. We have lightning, it is flow of electric charge. But now let us try to understand. Okay, what is this? History of charges. Thales is a king from Greece. He was the person who did a small experiment with this. Okay, look at this. You have the American freedom fighter, Benjamin Franklin. So the year is 1752. Look at this. The year is 1752. Americans, they got independence and they were developing science. And in India, Robert Clive was attacking Sirajud-Dowlah in 1757. We had the first battle of Plassey. Okay, look at this now. So this Benjamin Franklin, he was doing an experiment. He wanted to check this lightning is made up of what. So once there was heavy rain, so he took a kite. He tied a key to that rope and he was flying it. So there was lightning, and after lightning, he took that kite down. He checked this key with an ammeter, and ammeter deflected. Then he proved that lightning is nothing but it is consisting of electric charges. What is that? Electric charges. And you won't believe it. This was a question asked in your examination. Who among the following did an experiment on electric charges? They gave Einstein, Thomas Alva Edison, Benjamin Franklin, like that. Many students, they will think Benjamin Franklin is a freedom fighter from American Revolution, but he was also a great scientist. You understand? So basics of static electricity. Imagine this is a block of wood. Each matter is made up of tiny particles known as atoms. Atom consists of three main parts. What are those? Protons, neutrons and electrons. So P stands for protons. Okay, it is plus positive charge, because it is positive charge. Neutron is no charge. Okay, so I am writing it as 0. Okay, I am taking it as 0. And electrons, they have negative charge. They always revolve around the proton and neutron. Okay, look at this. This is the basic structure of an atom. Positive charge is proton, okay, and electrons, negative charge. The charges on proton and electrons are numerically equal, or you can say the charges on a proton and electron are equal and opposite. That's why they become neutral. Atom is neutral. Okay, now look at this. Positive and negative, they become what? Neutron. Do you all understand? Positive and negative, it become what? Neutron. Okay, so in an atom, the number of proton are equal to number of electron. Look at this once again. Okay, The proton, number of proton. How many proton you can see here? 3. How many electrons you can see here? 3. So every time you remember, number of proton will be equal to number of electron. Do you all understand? Hence the total positive charges is equal to the total negative charges. The atom is electrically neutral. All okay. Now look at this. Types of charges. I'll clear your doubt later. Look at this. Types of charges. The central part of the atom is called as nucleus. The nucleus consists of protons and neutrons. Protons are positively charged and neutrons are no charge. Neutrons, no charge. Now you have electrons revolving around the particular orbit. This is how the atoms looks like. Okay, all the atoms will be like this. This yellow part is called as the nucleus, and electrons are revolving around the nucleus in a particular orbit. Now the one electron is free. Imagine it goes out. Now this guy is free. He will keep roaming, and this roaming of these charges is called as electric current. Okay, so imagine this is a plastic straw. One free electron, it went and sat on this plastic straw. Okay, and now this is polythene, and here you have many free electrons. Okay, and all these free electrons come on this plastic straw. Okay, so this is called as the static electricity. Okay, so straw has excess electrons, hence it has negative charges. Polythene has lost electron, so it is positively charged. Always remember, the person who has more electrons will be negative, and person who has less electron will be positive. Okay, very important. So hence it is positively charged. Okay, now look at this. Charging by rubbing. Imagine this is a cloth and this is a plastic stick with you. So when you rub a glass rod in a silk cloth, the electrons are going from this stick to the cloth. So now tell me which one will be negative? The cloth will be negatively charged because it has more electrons. Okay, so the rod is positively charged and the cloth is negatively charged. Okay, look at this now. This is a fur and you have an ebonite rod. So when you rub against each other, so from the fur, what happens? The electrons will travel on the ebonite rod. So now tell me which one will be negatively charged? Ebonite rod will be negatively charged. Okay, so this loses electrons, so that becomes positive, and the ebonite rod will become negatively charged because more number of electrons are there. Okay, look at this. Electron transfer, reason of frictional theory. In both the cases, there was friction. Due to the friction, there is transfer of electrons from glass rod to silk and from fur to the ebonite rod. The electron transfers due to the friction is called as frictional electricity. On rubbing the two bodies, electric charges are developed on both the bodies simultaneously. So these are all things you have already understood. Static charges. This is a plastic straw which has more number of electrons. Can the charges flow through the straw? Yes or no? Can it flow? Okay, we'll do some experiment and we'll try to understand. Plastic is a poor conductor of electric charges. Okay, so can the charges flow through the air? No. Air is a bad conductor of electricity. Remember that. Air is a poor conductor of charges. Hence, the charges cannot move. The electric charges which cannot move are called static charges. They are called as static charges, or it is also called as static electricity. Okay, now two charged glass rods repel each other. Look at this. This is a glass rod which is positively charged. Okay, and I am tying it with a stand on a rope. There is another glass rod. I have two glass rods. One glass rod which is positively charged, another glass rod which is positively charged. If I bring this glass rod towards this glass rod, what happens? They will attract or they will repel. Look at this. When I bring it closer, the glass rod which is tied, it starts moving away from this glass rod. So they are going to repel each other. Okay. The suspended glass rod moves from the other way. So they are positively charged, they repel each other. Remember that. So what happens? What is the conclusion? Like charges will repel each others. Okay, next. You have two charged ebonite rods repel each other. Once again, the same experiment, negatively charged. I bring another ebonite rod which is negatively charged. I bring it closer. What will happen now? They will attract or repel? Yes. Again, here also they are repelling. So the conclusion is like charges will repel each other. Okay. Now look at this. There is a glass rod positively charged and there is an ebonite rod which is negatively charged. Now what will happen? Attraction or repulsion? Yes, now there will be attraction. Okay, so we observe that the ebonite rod moves or tends to move towards the suspended rod. So unlike charges attract each other. Do you all understand? Law of electrostatic forces, two like charges repel and two unlike charges attract each other. Now let us try to understand electroscope. Okay, so this is a glass bottle. This is the metal foil and it is earthed. Insulator plug. We have a brass disc and a brass rod, and here you have aluminium strip. Okay. Detection of presence of charges. The presence of charge of a body is detected with an uncharged electroscope in the following way. Yes. By touching the body on the brass disc. Imagine the body is tested. Whichever I want to test, I will touch that body on the disc. The divergence of the leaves is observed. Following two cases can arise. Case 1. I take a rod and touch this disc. Now what happens? There is no effect on the leaves. These are the two leaves. Okay, these are the two leaves which are little bit away from each other. There is no deflection, no attraction, no repulsion. It is as it is. So no divergence. Uncharged body. That means this body is what? Uncharged body. Now case number 2. If leaves diverge, the body is charged. Okay, imagine I brought a body and touching to the string. Look at the leaves down here. It is going away. Okay, so the body is charged. Okay, now the disc and the rod and the leaves all share the charged body. So in case 2, what happens? The body is positive. So the charge on brass disc, rod and leaves the positive electrons. You understand? Look at this. Positive charges, they go and they repel each other. They go far away. Due to the like charges on the leaves, they diverge. Okay, next. But if the charge on the body would have been negative, the charge on the brass disc, rod and leaves electroscope would also be negative. So that time also there will be like charges and like charges will repel each other. Okay, so that's the end of the lid now. Leaves will converge. So what do you observe now? They both are touching each other. So the strips come back to the original state. Why does this happen? The foil strip lose their charge through our body. So our body is a good conductor of electricity. Yes or no? Yes. So what happened? The charge which was here, when you touch it, the charge will come back to your body and it will go down to the earth. You understand? Okay. Now look at this. Consider this to be a charged body, and when a person touches a charged body, now tell me what will happen to him.
He gets shocked.
Okay, the charge will flow from his body and it will go to the ground. That's why it is told that not to touch electric appliances with bare hand, because your body is a good conductor of electricity. So the charges flow, it goes to the earth. This is called as earthing. Now we'll try to understand. The process of transferring of charge from a charge to the earth is called as earthing. Okay, look at this now. We'll understand the phenomenon of lightning. Very important. Clouds. So these are the clouds during rainy season. This is air. Now tell me, air is a good conductor of electricity or bad conductor of electricity? Bad. Okay. Now look at this. This is earth. Just now we have seen the electrons flows inside the earth. Correct? From our body, the electrons will go where? To the earth. Okay, look at this now. Air is a bad conductor of electricity. The air current moves upwards. So here there is air. Okay, here there is air. The air keeps moving upward. And here what do you have? Clouds. Okay, look at this now. What happens? Water droplets move downwards. There is rain. Okay, and due to rain, what happens? The positive charges collect near the upper edges. On the top of all the clouds. On the top of all the clouds, there will be positive charge. Okay, and look at this. In the bottom of the clouds, what do you have? Negative charge. Okay, now tell me, like charges will attract and unlike charges will, sorry, like charges will repel and unlike charges will attract. Okay, so look at this. On the ground, what happens? On the ground, you have positive charges. What do you have here? Positive charges on the ground. So look at this. The positive and negative, they attract each other. So from the clouds, the electrons, and from the earth, the positive protons will try to attract each other. And that is why you have lightning. That is why you have what? Lightning. So the lightning which is coming on the ground, it is due to the electrons in the cloud and the protons on the earth. Okay, so this is happening due to electric discharge. Next, sometimes you can see lightning inside the cloud. Okay, look at this. What happens? So the attraction of positive and negative, here you have lightning inside the cloud. Okay, so this is the phenomenon of lightning. Electric discharge between cloud and the earth or the cloud is called as lightning. Now look at this. This is called as lightning conductor. Here there is a building. Okay, on every building there will be a lightning conductor. Now why this lightning conductor is kept? To save the building from the dangerous lightning during rainy season. So the lightning conductor has a pointed sharp edge which is made up of copper, okay, and a thick rod. So here this is thick rod and it goes to the ground directly. Why? Because the electrons will flow to the earth. So this is called as ground. It goes to the ground. Okay, if the lightning strikes, look at this. If the lightning strikes, the electron will flow and it will go to the ground. Can you see that yellow color electricity flowing? It goes to the ground and the building will be safe. Your electric appliances will be safe. Nowadays, now the building contractors or engineers, they are trying to follow this method. Everywhere the building is made up of this copper strip and the copper strip is grounded here. So what happens? This gives more safety for the building. Okay, so this lines which you can see is called the copper strip and it is earthed and your building is safe. You understand? Now, safety. How to be safe during lightning? Remember one thing, nuclear explosion, Hiroshima and Nagasaki has killed lakhs of people. Agreed. Every year there is disease, Ebola, typhoid, malaria. People die. Agreed. Okay, earthquake, people died. Flood, people die. So many disasters are there. People die. But the most dangerous disaster and the maximum number of death is lightning. What is that? Lightning. So which is the natural disaster maximum which is responsible for the death? That is lightning. Both animals and humans, they both suffer. Look at this. How to be safe during this lightning. Do's and don'ts. Very important. Outside. When you are outside and there is rain or light, how to be safe. Look at this. First of all, if you don't travel in an open car, okay, don't try to travel in an open car. So if you have that, what is that, abhi open car aata hai na upar, rooftop. Rooftop, you want to enjoy rain and you're traveling in rooftop and suddenly lightning came, that's it. Okay, so open cars are not safe because it becomes an easy target. Okay, it becomes an easy target for the lightning. Next, don't stand under a tree. Don't stand under a tree. So the tall trees are not safe. Okay, so what happens? You may die. समझ में आया? Fine. Next, can you carry umbrella? What happened? Yes. Yeah. So what? See, the logic is, if the surface area is greater, okay, on your head, if you are covering something with large area and there are some steel rods, something like that, electricity will directly go to that good conductor of metals like that. Next, don't try to go on the mountain. Okay, big hilltop. Okay, hilltop, kuch bada mountains. Don't try to go there. Okay, so what happens? You may die. Next, what you can do, you can sit in this position. So when you sit in this position, you will be saving yourself because the lightning will not reach you. Okay, so place your hands on your knees, head between the hands. This position will make you the smallest target. Okay, next, when inside the house, now imagine I told you don't go outside when it is raining. So can you spend time in home connecting your friend and talk on this telephone? What happens? Look at this. What happens? Those days this was common. Okay, the phones will die, landline phones will die, but nowadays it's not there. Look at this. Inside the house, what you can do? Imagine it is raining outside and you took the phone. The wire is a good conductor of electricity. So sometimes lightning will travel and you may get shock inside your home. Got it? Next, what can you do? You can use mobile phone. Okay. Next, TV. Can you watch TV during rainy season? Have you ever seen parents will say that TV band kar do, fridge ka wire nikal do, right? You will go back to the cave life once again. Even if there is 3 hours of rain, you will be like a ancient man who lives in cave. Correct? So look at this. The wire, it will bring the electricity and your TV will be damaged. Next, inside the house, imagine अभी कुछ भी नहीं करना है, चले गए बाथरूम, okay, चलो we'll spend time here, okay. Lightning can strike on the metal pipes also, okay, and you may die in bathroom itself. ठीक है? Okay, so these are the things that you have to keep in mind. Fine, that's it. So tomorrow I think we have last one chapter, light. So but it's a lengthy chapter, we'll do it tomorrow. Okay, so did you all understand?
Yes, sir.
Yeah, so switch on the lights now quick.